Welcome to homework.
Okay, this one is actually kind of a weird question because they don't tell us how many silicon atoms, how many oxygen atoms, right? And if we were to recall that silicon will bring 4 electrons to the party, being from group 4A, and that oxygen, being from group 6A, will bring 6 electrons to the party, we've got, 10 electrons to work with: silicon, oxygen. And if we want to obey the octet rule so that everything sees, uh, 8 electrons, there's no good way to do that with 10 electrons, right? That there's simply, we could put a double bond here, and then we've got maybe a lone pair there and 2 lone pairs here, right? Actually, this works. That's fine. Yeah, this is probably it, right? Because in terms of charge, silicon is seeing uh, 2 times the number of lone pairs, right? Plus 1 times the number of bonds, which is equal to 2 times 1 plus 1 times 2, which is equal to 4, which matches its group, so it's neutral. Right? Okay. What about oxygen? 2 times the number of lone pairs plus 1 times the number of bonds. That is 2 times 2 plus 1 times 2 equals 6, which matches its group 6A. Right, so it's neutral. Okay, and then in terms of the octet, here's the issue. Silicon does not have a full octet. 1, 2, 3, 4, 5, 6. So that's no good. Oxygen is satisfied, but silicon is not. And in fact, with a single silicon atom and a single oxygen atom, there's no good way to draw this. So I don't know if they just wanted you to leap ahead to this. But just like carbon and oxygen, the simplest compound, which, makes any sense with the number of electrons that carbon and oxygen bring to the party, is CO2. And since silicon is isoelectronic, at least in terms of its valence shell with carbon, then we should also expect that SiO2 is going to be the simplest molecule that obeys the octet rule that we can draw for any combination of silicon and oxygen atoms. And what's interesting is that this indeed is the formula, SiO2, that silicon and oxygen take in the world, like all over the world. This is the formula for sand. Oddly enough, it doesn't take this form. This is like the single molecule form. In fact, what we see is silicon forming a network of bonds in which every oxygen atom is shared between 2 silicons. These are not sulfurs. These are right. Point being that every silicon atom sees 4 oxygen atoms, but it's sharing those 4 each with 1 additional silicon atom. So in the end, it averages out to SiO2. And in the single molecule form, this is a representation of SiO2, which paradoxically does not really exist in nature. But it is the simplest compound respecting the octet rule, which can be drawn by combining silicon and oxygen atoms, nonetheless.